It's really exciting to be introducing this series of talks, which is the future in blockchain, at Imperial College London, Faculty of Engineering. Today, hosted by a collaboration with Mana Labs and the NEAR Foundation. For those of you who don't know who Mana Labs are, it's our research group on the future of work and blockchain at Dyson School of Design Engineering. Together with researchers at Imperial College and the Mana Group, we will be working on developing scientific research on how the blockchain technology will affect leadership, organizations, and the future of work. Fun fact, McKinsey experts estimate that by 2030, 375 million employees worldwide will have to retrain, and 70% of today's learners will work in professions that have not yet arisen. In a context where skills in blockchain are becoming essential to address the most pressing issues of the century, this series of talks will introduce the underlying concepts behind blockchain technology and discuss how to start a career in this space. The seminars are open to students and professionals interested in understanding the current state of blockchain technology and networking with key actors in this field. Today, we're kicking off with the developer introduction presented in this guest lecture with Sherif Abushadi, Head of Education at NEAR Protocol. So it's a pleasure to have you here at Imperial College. Sherif, without further ado, over to you.
Okay, nice, thanks. I appreciate that, Lloyd. I have here with me my colleague, Katya Abramova, who is a data scientist and instructor on the education team as well. So thanks so much for joining us, Katya, on such short notice.
Hello, everyone.
We can go with a brief round of introductions between the two of us. And I don't know, Lloyd, if you have other people who are in the waiting room as well, but I invited a couple of other folks from our team that might be able to help kind of add a little bit of dialogue to the conversation.
Not at the moment, but I'll keep an eye on it.
Yeah, great. Appreciate that. In terms of interaction with the audience, it looks like we have a maybe 30-second, 1-minute delay on the chat in the YouTube live stream. So I have that open. If anybody has questions who are watching the live stream, feel free to post your questions there, and we'll do our best to address them in a reasonable amount of time. I think just a quick time check. We have about 50 minutes left in the call. Is that correct? So very briefly, then I'll just introduce myself, and then Katya, if you can introduce yourself, and we'll start with a kind of high-level overview of the NEAR platform, NEAR protocol, NEAR foundation, and then kind of dive into some of the questions if we have any. If not, we have plenty of content to support a kind of dialogue between Katya and myself. Lloyd, if you want to lean in, or just kind of giving you a sense of what we've got available for you. So my name is Sherif. I run education at NEAR Foundation. I've been building software for 25 years. I've been teaching for 20 years. I've taught about 4,000 adults, a little bit more. I've worked as a software developer, senior engineer, architect, management consultant, corporate trainer at 220 companies, maybe a third of the Fortune 100, a quarter of the Fortune 100, maybe 10 US federal agencies. And help start several ed tech businesses, sometimes as a member of the founding team, sometimes as a co-founder or sole founder. Notably, Dev Bootcamp in 2012, and ran Galvanize for a year, and then Adjacent Academies just before joining the NEAR Foundation in 2019. It's a pleasure to be here. Thank you so much for your attention, and hopefully it's a good use of your time. Katya, can you make an introduction?
Yes, so thank you for having us. It's great to be here. I'm an adjunct assistant professor at London Business School, where I teach machine learning, programming, and statistics. Also, I did my PhD at Imperial, so I'm actually an alumni. I was at the computing/bioengineering department where I completed my PhD in machine learning. Specifically, I combined algorithms on optimal control and reinforcement learning. And prior to that, I have financial background, so I actually traded for a few years and worked for New York Stock Exchange. And now I work at NEAR Education, so for the NEAR Foundation. And yeah, we're very glad to be here, so thank you for having us.
Nice. So I think just to kind of get started, the question is, how should we frame this? Maybe we can spend a little bit of time talking about what is blockchain technology, if that makes sense, Katya, we can do that. And what we're seeing in terms of applications and use cases. And then I think a brief introduction of what we have in terms of educational resources, and then see if we have questions at that point. So all that can probably fit in about 10 minutes. So maybe Katya, if you could play the role of kind of the student with zero activation energy. The minute I say something that doesn't make sense or isn't clear, you can kind of stop me and say, wait a second, like, what do you mean by that? Is that okay? It's good to have a little bit of fast feedback. Yeah?
Sounds good.
Okay, nice. And Lloyd, obviously feel welcome, but no pressure.
I can definitely play that role.
Perfect. Yeah. So I think if we want to frame blockchain, we need to frame it first of all in the context of human history. So bear with me here, and I will do my best to kind of tell you a story. This device here that I'm holding in my hand, this mobile phone that you see, imagine if you took that back with you. It's not such a fancy one, it's Samsung, whatever. If you took that back with you 25 years, 30 years, and you showed it to your friends in the mid-90s, let's say, assuming that that you're old enough to do that. If not, that's fine. But just pretend for a minute that you're in your 30s and you can do that. And so you went back and showed it to your friends and family and explained to them what you do with this device today. This device, first of all, it's always on. It's always connected. And it's strange if it's not, in fact, right? If I try and sell you today a mobile phone that doesn't connect to the internet, you would laugh. Doesn't make any sense, right? It seems strange. So it's always on. It brings you information at the touch of a button, what's the weather, whatever. You can even talk to it. You can ask it, what's the song that's currently playing? And it will listen to the environment and then bring information related to that environment, right? All these things are obvious, not surprising at all. And I can give it things that I care about to contribute to the experience of others online, maybe through Instagram or TikTok or whatever, some live streaming, application, Twitter, whatever it is. I've got a comment about something that just happened in the news. So you've got this connection and you've got this data that comes and data that goes. All of that is available in this device that you can get for the price of a nice bottle of wine or whatever. And everybody has it. Billions of users around the planet now. So this is part of a larger trend from maybe the 40s and 50s, where computers were the size of houses and buses, shrinking down now to our pockets and wrists. The connection of these computers starting, in maybe the 60s and 70s, ARPANET and other networks connecting universities and then, communities through bulletin board systems and things like that, affinity groups who are interested in games. And then bringing us data of the world through the internet of the 90s. And finally, Web 2 being able to take what we have, Facebook and, Twitter and other ways that we can contribute to the internet, innumerable ways now. You can build websites in a matter of a couple of hours with a good idea and a kind of fast typing. So all of this infrastructure that we have, all of this basically opens up possibilities that we can hardly imagine, but all we get in terms of the new primitives, everything I've just talked about, are basically data and space, data moving through space, the guaranteed delivery of data through space. That's what we have, TCP IP or whatever. And of course, the computer that sits in our pocket to manage that data. Blockchain and when you talk about blockchain, is introducing new primitives, brand new primitives. On top of data and space, we get these other two new primitives. What are they? Hold that thought for a few seconds. Let me see if I can tell this story in a nice way that's entertaining for you. Imagine that I gave you an apple. In the moment that I give you an apple, something has happened. And imagine then that you take a bite out of it, something else has happened. Let's zoom in there. The giving of the apple requires the passage of time. I'm not trying to be clever here. I'm just suggesting that you can't give an apple in 0 time. Some time passes. And when I give you that apple and you take a bite, you've irreversibly changed that apple. You know, entropy and all that kind of good stuff. You can't somehow reconstitute the apple. You need to go back and grow another one. And so in the world that we live in, the real world, the non-digital world, we are very comfortable with this idea of the giving of an apple or the spending of $1 with a serial number that can't be forged and so on. The idea that time passes and we control identities, various identities. I don't know if it's a bit of a stretch in our reality. The apple is a unique identity in the universe that you can mutate by taking a bite or regrow another one, different identity, different apple. The dollar that you can spend, you know, a single serial number, you move it through time to give it to somebody else, you know, whatever it is, it's got a unique identifier there. You can't respend it. And so identity and time are these two new primitives that blockchain brings, bringing the missing pieces from the real world into the infrastructure of the digital, where we already have guaranteed movement of data through space. So that's the big idea. You have a clock, a public clock that is paying people to keep it ticking, whatever the consensus model is, proof of work or proof of stake. And through some cryptographic primitives from the 1970s, you can, you know, prove that you are a unique identity, essentially public-private key pairs, and you can, you know, sign a transaction to prove that nobody else has actually, you know, messed with this transaction. So we have data and space for 80 years now, and we have identity and time for 40 years now, with the time component, the shared clock, just 10, 12 years coming. The identity has been around since maybe 1976 or something like that. So, and several people have tried to build something like this, you know, hash cash, V-money, I don't know what, several different attempts maybe in the last 30 years, but 2009, 2010, with the Bitcoin white paper, we saw the first example of this clock. In fact, 3 of the 8 references cited in the Bitcoin white paper are about decentralized timekeeping. And quoted from the paper is something about, you know, we need a way of, you know, agreeing on time and the movement of time, fundamentally. And then money, and what, you know, everybody seems to be getting excited about, you know, speculation around, you know, crypto and so on. It's really just a use case that you can put on top of this system. And that realization, that argument was made by Vitalik Buterin when he brought Ethereum and said, we don't just need to track money and some metadata, IOUs, what Bitcoin tracks, we can actually track any arbitrary data in this clock. Let's track smart contracts. Let's track these functions that live on the blockchain. And when we call them, whatever they do and whatever they return, whatever comes out, all of that can be tracked. The inputs, the outputs, and the code itself can be tracked in this clock, not just the you know, BTC or ETH that leaks out per tick of the clock to pay people for keeping it ticking, but we can also track these smart contracts. And so fast forwarding to 2019, 20, 2021, we have Near, Avalanche, Solana, Polkadot, Cosmos, Tezos, and others that are taking the Ethereum model and making it faster and cheaper and more scalable, more human-friendly, basically, to work at the speeds of Web 2 that we're used to, fast finality and, you know, infinite scaling and all that kind of good stuff. So that's what blockchain is. That's the big idea. Maybe that's interesting for some folks in the audience. Any questions or comments or points of clarification, Katya, Lloyd, on that?
Nope, made complete sense. Thank you.
I would love for you to talk a little bit more about Near and the other blockchains that we currently have, and what advantages there are presently with these blockchains versus Bitcoin and Ethereum for our audience to understand.
Sure, yeah. And again, I mean, I think for me, it's been useful to think about this in terms of kind of phases. So the innovation, the invention was Bitcoin that brought together this collection of technologies that was unique and was sustainable. It actually worked for the first time. Where we have a public ledger, that's a necessary requirement of this technology. We need the information that we're capturing needs to be in public so that all of us can agree on what just happened a moment ago. In fact, in the last tick of this clock, whether it's Bitcoin ticking every 15 minutes or Ethereum ticking every 15 seconds or Near ticking once a second, whatever it is, we all have to agree on what just happened. And so a prerequisite of that is that we have everything in public. That's one piece of it. We have public-private key pairs, for cryptographic signatures that are irrefutable. Essentially, when we sign a transaction, it's mathematically impossible to fake that signature. And then, we have this mechanism for arriving at consensus, sort of broadcasting the truth and then agreeing on the truth, disputing the truth, and for, recognizing that someone is sort of, messing with that truth. So on top of that, Ethereum added a virtual machine that runs Solidity bytecode. Basically, you write smart contracts and then you deploy them to the network, and there you can execute them by calling the function remotely. Think of it just like pressing a button to make it run. Not a big deal. It runs. It does its thing, and that the Ethereum clock ticks at 15 seconds, whereas Bitcoin ticks at 15 minutes. The latest, or this third generation of these blockchains, if we want to talk about them as a group, are taking the Ethereum sort of single-threaded model and parallelizing that. Fundamentally, that's what they're all doing. So Near, Polkadot, Avalanche, Solana, we're all parallelizing this, but in different ways. So we can start with Solana. Their mechanism for parallelizing is to take this thread of things that are happening in reality, right? Whatever they are, the things that happen on chain, as fast as they come, and then at some point, time stamping them very quickly, whatever it is, tens of thousands of times per second, time stamping them, and then parallelizing them, handling the work in parallel, and then merging that work at the end together into a single thread of history. That's how Solana works, more or less. A lot of hand waving. I'm sure I'll hear some critical feedback from the audience, but there is a thread of things that are happening. Presumably, they get time-stamped, parallelized, executed, and then merged into a consistent history based on the timestamp that they received earlier. So that's Solana. Avalanche takes what's happening and specializes it and says, everything related to governance is going to happen on one chain. Everything related to value and token exchange is going to happen on another chain, and everything related to, say, Ethereum functions and contract execution is going to happen on a third chain. And through that specialization, we can get massive increases in performance. So that's how Avalanche works. Again, I'm waving my hand, incredibly simple, and feel free to comment and criticize and clarify in the questions. If there's pieces here that are off, happy to learn from you as well. And then if you talk about Near and Polkadot, it's a similar approach in that we have sharded compute and storage. And Near is the only innovation with both sharded compute and storage, where Near basically says, let's have the chain, the blockchain, whatever the history is, as a logically single thread. So history is just one logical thread. But then at the block level, for each tick of the clock, we can split up the work among shards. And then people can work on one shard without having to maintain a copy of everything that's going on. And so that way, what you get is sharded design, nightshade, these kinds of things you hear about with Near, is that the number of shards is really where the scale comes from. And I might be running a validator that is working on helping to build the chain at this one shard, but the block, the tick of the clock, is actually a logical connection of all of these shards together. Tick, 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 like that. Lloyd.
Sherif, Thanks for walking through that. Specifically there with the shard, is it doing it with the methodology that you just mentioned technically, but discounting specialization?
So with Near, there's no specialization of the chains. Like Avalanche, there's one logical chain in Near. And in fact, to be a validator, you have to run the standard Near core. There's one implementation today in Rust, but there could be other implementations of this client. Obviously, there may be some others in progress. I'm not aware of them. But Near core, you have to download that software, sign up to be a validator. There's a process of onboarding and sort of verifying your ability to keep up with the ticking of this clock that happens fairly quickly. And then you have to put some money at stake. Essentially some Near tokens, you're putting some significant capital, staking it, saying, I swear I'm not going to lie. And if I do, you can, take some of this money that I'm putting as guarantee of telling the truth, right? That's how proof of stake works. And then each validator works on solving their part of the tick. So again, there's these shards, there's a little piece of it. You may track all of the shards if you want to. If you're running, say, an archival node or indexing node, and you want to be able to query what's happening in the history of the chain, then you're not helping with the ticks, you're just following along with the ticks. As a validator, you can choose to subscribe to as many of these shards as you want to. But if you just want to follow one of them and focus on being a chunk-only producer or something like that, then you can just focus on one of these shards like that. You may even skip some of the ticks if you need to, and that's okay too, as long as you maintain some level of consistency and ticking along. I didn't complete the story about Polkadot, which is essentially a single thread that is consolidated by connecting other blockchains around it in kind of think of it like a star shape. That's the image that the Polkadot team seems to be sharing publicly. And so this can kind of go out like a snowflake, if you can think of it like stars of stars. I'm not sure how many layers out you can go, but the big difference is that with something like Polkadot, each one of these leaves on the flower or the snowflake can have its own consensus model, its own economy, its own native token. Whereas with Near, it's all a single shared security model, single shared token. Everything is the same, but you're sharding the storage and compute. So those are some distinguishing features there. And then if we talk about interoperability, Near in particular has Aurora, which is effectively a layer 2 solution for Ethereum. So you just, if you're used to working with Ethereum, you can just switch your network and target Aurora and deploy your Solidity contract there. It'll run faster and cheaper on Near. And through Octopus Network, we have a kind of model that's compatible with inter-blockchain communication protocol, IBC, the Cosmos model. And that gives us the ability to connect with other chains in the ecosystem as well. We also have the Rainbow Bridge that lets you move assets and value across the boundaries of these chains, and some other integrations that have recently been announced, multi-chain and other things like that. So you can track that on near.org in the blog and so on for all the details. So hopefully that gives you a sense, Katya, of how these things compare. I don't know if that was clear.
Yeah, perfect. Thank you. I guess one final thing, given the time that we have, I wanted to ask is, now that we have these fast, cheap layer 1 blockchains, what would be the use cases that you see for now and the future that might be interesting to our audience?
Well, I think it's natural that what we've seen is a lot of speculative behavior with, token prices and, kind of, everything going to the moon and that sort of stuff. But it's really, in my mind as a technologist, I can tell you it's a big distraction. It's the kind of the questions that we have are about, I can tell you in some of our courses that we offer, people might say, is Near this kind of token or that kind of token? Should I get excited about that? It feels similar to someone asking in the mid-90s, which email address should I have? It's like that. It seems like an important question because you see people talking about email on the news and you read about people getting emails and what's email. And so you think like, let me focus on that. But actually the value is nowhere sort of around that. The value is in the applications that you can build. And that's like, in the mid-90s, nobody had thought what you could do with JavaScript. Whenever JavaScript was invented, it was years away before we had Gmail as an implementation of like serious client-side JavaScript. And then from that, we saw lots of other applications growing. So with blockchain, what you want to really keep in mind is the clock that's ticking. So what you can think about is the blockchain as the clock that's ticking and keeping the data in that clock. What do you want to track in your application that you will guarantee to your users will always be true? What segment of your application can you say, no one can lie about this, that will add value to your user community? That is the class of applications in general that would be useful in technology like this. Anything that happens in time that you don't want to lie about. So think of any sort of records, anything that you want to sort of exchange through time, ownership, for example, or anything, any segment of your application. At one point, you sort of want to record it and say, you know, we're not lying about this. So let me zoom back from these kind of abstractions and ask you a couple of basic questions. Like, Lloyd, if I asked you, like, what's your full name? What would your answer be?
Lloyd Ahmed Mohammed Reslin Abdul Wahed.
Nice. And so then let me say, I'm surprised by that name. It's quite a name.
Yeah.
So let me ask you then, how would you prove that? Prove that to me. What would you do? You would produce
Passport.
something, some artifact, right?
Yeah.
A driver's license or a passport or a military ID or a student ID or something like that, right? You would produce something which is difficult to lie about, right? And has been recorded at some point in time with an authority.
Yep.
It's a piece of data that is hard to lie about, or you can't lie about. I mean, maybe you can counterfeit passport or something like that, but let's say piece of data you can't lie about that's been recorded, officially recorded at some point in time. That is the definition of an NFT, by the way. Right? That's why people are excited about NFT. So NFT as a concept is really just an ID that is attached to a user account. And that attachment you can't lie about, the user account you can't lie about, the ID you can't lie about. At a point in time, that connection is made. That's what an NFT is. The fact that you also have this other metadata, a picture, an algorithm, a swimming fish, or a laughing clown, or whatever, that's all incidental. Think of it like a spreadsheet with two columns, ID, username, and then any other columns you want to add. All the other columns is what you see in the news and, you know, works of art and music and all that kind of stuff. But the metadata is unlimited, basically, right? You just have to deal with that somehow. You have to put it somewhere, you have to render it somewhere. But the key is the ID connected with the ID of this row in the spreadsheet, you could say connected with your username. That connection is the key. So you talk about applications, I mean, it's quite significant. Where did you study? You might say, you know, Imperial College. I might say, okay, well, fantastic. Prove it. What are you going to show me? You're going to show me some proof of credential that's hard to duplicate, recorded with an authoritative body at some point in time, right? So, what car do you own? You know, I don't know what Volkswagen over there. Prove it. You're going to show me again some piece of data that's hard to forge, recorded with some authority at some point in time. So anything around time and identity is part of this story. Value is baked into the protocols because you need something valuable with which to pay people to keep the clock ticking, to keep time running in this artificial space, this digital space. And then the combination of identity and value gives you ownership, and the identity of ownership and time gives you maybe provenance, where things have come and gone. Those are maybe 5 sort of primitive combinations, but it's really identity and time are the 2 big ones. So.
Okay, perfect. Thank you very much for that. How about some other use cases recently that we have seen NEAR been able to deploy, such as, for example, we have had the conflict happening in the Eastern European bloc, and we've been able to actually respond very fast. Could you please talk about what allowed NEAR to respond and offer help in this instance?
Of course, yeah. You know, the crisis in Ukraine really hit home. We have co-founders of Near that are Ukrainian. Much of the deep technical talent actually at Near is either from you know, cities like Kiev and Kharkiv that were affected by these events, and so immediately we felt what happened, you know, across the organization and across the ecosystem. What I think you're referring to, Katya, is that that there were a number of people who thought, you know, we should really do something to support, you know, the folks on the ground in Ukraine, and so there was an initiative that was launched. And right now, I'm sorry, I'm not remembering the details, but if you have them, you want to post them. I know there was an account made, a root level account in the Near protocol called Ukraine, as opposed to most accounts have like a, you know, something .near, like Sherif.near is my account name, but a Ukraine account was made to help support the collection of funds and the direction of funds. And some millions or tens of millions of dollars were, you know, routed through this organization. Again, I'm forgetting the name, Katya, if you know it, maybe you can share it, but within a matter of days. So it was really remarkable how quickly that happened. And this was, I think, if I'm not mistaken, one of the largest, if not the only, such kind of massive funding efforts direct to, you know, an area with some, you know, conflict-afflicted area, directly to the individuals that needed it, directly to the, you know, the state and local governments that needed to act on that. So
yeah, so this really shows that we're able to use this technology and actually respond in real time, and, you know, with real issues. So yeah, so thank you for that.
Nice. And there's somebody in chat here who's reminding us it was Unchained DAO that was Ukraine Unchained, and the Unchained DAO, I think, is what it was. Thank you for that.
Sherif, there's a really nice comment as well. Just saying that you explained through the different protocols and user cases really well. So thanks for that. So we're at this really inspiring moment. If you're, you know, in education, if you have a STEM qualifications, or certainly an appetite to be in the frontier of, you know, a new dawn of technology, like you say, the ambition is still just to make great products that are incredibly useful. And so we can talk about user cases perhaps at the end, because there's some very exciting ones that are starting to emerge. You mentioned NFTs, we have DAOs, we have DeFi, and so on and so forth. But actually, I thought, because this is focused on developers, I wondered if you could talk to how developers should be thinking about perhaps what they could be upskilling in, or how they can get involved in communities right now. So, you know, whether they know what user case they're excited about or not for the next year or two, they can start preparing themselves for a career in what is probably, you know, a generational technology shift.
Yeah, I mean, it's hard to overestimate the potential impact of something like this. Again, you know, the more difficult question isn't sort of what will go on chain. This is going to touch almost every part of the way that we work and live and organize ourselves at every imaginable level. But when will that happen? It's like, you know, living in the 50s, 60s, seeing us go to the moon and saying, oh, next year we'll have computers that are doing our laundry and, you know, driving our cars and stuff. It's, you know, it's the timeline is almost impossible to predict. But I can tell you, and a lot of it has to do with luck and, you know, various sort of other kind of surprising, you know, major surprising upheavals in the way the world moves. So again, and I'm not an expert in any way to talk about this, but I can tell you from what I've seen, let's say in the last 25 years, the best investment that you could have made in the last 5 years of the 90s is education. Lean into the new tools and the new ideas, and not at a surface level, kind of just sort of, you know, touching something or testing something, but actually sinking full in. So my best recommendation, if you're a developer in the audience right now, you've heard us mention, you know, Bitcoin, Ethereum, Near, Avalanche, Polkadot, Solana, Cosmos, Tezos, Algorand. There's many of these technologies. The best investment you can make in 2022, you've got about 6 or 7 months, is to go and learn all of these so that you could be the person in the room who knows how to have a meaningful debate about the differences between these technologies. Don't just learn one. I'm happy to send you to near.university to learn about what we have there. It's all free and there's lots of courses and self-paced content, and it might take you a few days to a week to build and deploy a working application. That's great. That's how I spend my time, is educating people about Near. But if you ask me what's my best advice to you as a professional developer, learn all of it so that you can have the deep debates and deep discussions. You could be the person on your team or in your organization that's helping people get a sense of what's going on in this landscape, and an investment like that in yourself and in what you learn over the next 3 to 6 months is going to pay off for a decade or more.
Sherif, one recommendation might be to start with white papers, but it's just a recommendation. Are there others that you have? And do you agree with that? Is that the place to start?
I feel like that's kind of you've kind of laid that one up for me to hit. I have to tell you, Lloyd, I am strongly opposed to reading white papers as an approach to learning, and I'm saying that only because the people that are writing these white papers, I mean, if it's like one of the meaty white papers, these are research level folks. These are, you know, master's, PhD level folks. These are competitive programmers with, you know, years of experience. The things they're writing about may be aspirational, they may be prototypical, the kind of prototypes they're working on, they may be things they've already implemented, but the chance that you're going to go from zero to clarity in the few pages that somebody who's years ahead of you has taken to distill an idea that they've been thinking about for years, it's very unlikely that you're just going to follow what they're saying. Sure, check out the white papers. I would say like next month, but this month, go and build stuff, because you're going to build an intuition, a sort of a visceral sense of exactly what this is and what this isn't. So when you're reading the white paper, you've got something concrete to think about. Otherwise, you're going to get lost in all the sort of heady possibilities. And then you might make the mistake of looking for the artifacts that you picked up in the white paper and the mental models you picked up in the white paper in the technology itself. And these are two different things. So one's an idea and one is design and one's engineering, right? Dive into the engineering, the APIs, the SDKs, the documentation, the examples. For senior developers, part of our training regimen is really just to hand senior developers like 100 examples. So go read this code and build something original. And that's what we measure as near certified. When we say someone's a near certified developer, they produce an original application. It doesn't have to be a unicorn, you know, significant $1 billion, whatever. It's just some sensible, representation of understanding. You can actually control this technology. You know what a contract is. You know what functions are. You know how to receive data and parameters and so on. It's a lot like writing any program, by the way. It's not such a big deal. People like that about Near, where they say that, you know, they've maybe tried others and Near is easier to understand. It's really because the brain trust at Near has made very clean abstractions for developers, so that when they're building, they're not thinking at all about the blockchain consensus, the runtime. All of that is completely abstracted. You're basically just writing something like serverless functions and deploying those to the blockchain, and they run there. So I would start there on the practical side, on the engineering side, and then go to the white paper if you want to kind of round out your understanding of what's going on. I wouldn't go the other way.
Yeah, I would also say that for the developers who are coming across into this space and they're very new to it, it's actually not as bad as it might seem on the outside, and especially if you don't have experience. You know, me coming from the data science background, it was very interesting to dive into it and learn it and, you know, write up a smart contract code, and it's not as bad as you might think. So I'd like to follow up on that with you, Sherif, actually. So I think in our audience, you know, we've obviously got engineering, the Dyson School. So most people would probably be used to MATLAB, a bit of Python, maybe some C++. But I wanted you to, as such an experienced developer, Sherif has got so many years, you know, writing experience in writing code. Could you also tell the audience what programming languages are currently going to be very useful when coming not just to Near, you know, to develop contracts, but maybe also other blockchains as well. So which languages would be the most useful for people to put their time into?
Sure, yeah, I appreciate the question, Katya. I think Before answering the question, it's good to have a mental model of like what's actually going on. Near can be extended in two ways. You can write a smart contract, a collection of functions, and you can deploy that, compile that, and deploy it. That's maybe extending from the inside. And then you can extend from the outside through the API. So it's a RPC API, JSON over HTTP, remote procedure call. We have language bindings for JavaScript and Python and Rust and Elixir and Ruby and others that you can use to communicate from the outside to invoke functions, send money, create accounts, all that kind of stuff that you do from the outside. So either you're extending from the inside or from the outside. So from the outside, any programming language that allows you to communicate using JSON over HTTP will work. And what I mean by the outside is like the front end of your application. When you log in, when you click a button, when you type something in, that's from the outside of the platform, just like you would build any web or mobile application, not a big deal, right? It's all the standard stuff. And we have these accelerators that wrap the API for you to help people build faster. From the inside, when you're building smart contracts, we have Rust, JavaScript, and assembly script. And so, Rust is a darling language, type safety, safety guarantees that you won't find in general, not just type safety, but because of the borrow checker and, all sorts of other engineering innovations. Rust is an amazing language, basically C++ without any of the foot guns. It's essentially like C++, but all of the parts that the developer would hold in their mind around memory allocation, deallocation, referencing, and so on is made explicit in the language. The developer doesn't have to hold that in their mind. The language actually makes all that stuff explicit. So Rust for writing contracts. You can also use JavaScript for writing contracts. So you can use our JavaScript SDK. You write JavaScript with a few additional decorations to prepare the contract. And then when you compile that, just like Rust, you compile to WebAssembly, you compile the JavaScript to WebAssembly, and then you can deploy that WebAssembly on the blockchain. And then assembly script, similar to TypeScript, it's a kind of a unique language that has some nice features and so on. And assembly script, you can take that, compile it to WebAssembly, and then deploy it. Assembly script happens to be very close to WebAssembly, sort of designed to target WebAssembly. So those contracts tend to be a little bit lighter, a little bit smaller. But JavaScript and Rust contracts are great for people who are learning. If you're coming from Go or C++, go straight to Rust. If you're coming from JavaScript or TypeScript, you can dive right into the JavaScript SDK. And again, that's the extension through smart contract versus extending from the outside, calling the blockchain to run things and do things from the outside through the API. That's another way to extend it.
Thanks, Sherif. We mentioned that we would move on to user cases to wrap up. Just a question on near university. If anybody would be keen to sign up, get in touch, what would your recommendations be? Where can they find you?
Appreciate it. I mean, that's really just it. Near.university. We have there dozens of courses. Some of them we have made, some of them the community has made. We have office hours you can register for, orientation sessions if you want to get certified, but you can really go to near.university today and see there are several different ways to engage with us through grants and fellowships and certification programs. There's also several self-paced courses, as I said. So lots and lots of opportunities to learn. And again, it is absolutely the best investment, in my view, of your time. And not just near, again, just to be absolutely clear, but several of these layer ones so that you can compare, because in kind of rotating this idea around your mind, in your mind, what you'll find is they all have data through space, identity, and time. And then how they bring these primitives together is what really makes them different. So it's quite interesting.
Thank you. And also just in terms of predictions, because we went back and you said, if you could have made the best use of your time at the end of the 90s, it would have been education. I assume possibly that remains true today, which is why you gave that advice. But you could also look back and say, it would have been very wise to become an engineer around the turn of 2000. You could, around 2010, have said it'd be very wise to have started to look into machine learning. And then, is there any type of technology prediction as we go more and more onto the blockchain, where you would recommend this could be a mega trend over the next 10 years?
I mean, it's a difficult question. I'll take a guess. Maybe Katya can offer a guess or two as well. I would say what we seem to be seeing is multidisciplinary kind of talent coming in. So the economics history major who knows how to read code and can manage a team is, launching an interesting project to revisit the way that we, sort of do peer-to-peer lending or something like that. I don't know what, right? The musician who, tinkers with electronics decides that they're going to launch some kind of music sharing ownership. I don't know what. So it's really sort of multidisciplinary work. What's interesting for me is that there will be jobs and roles that we have yet to conceive of that are coming. So that's quite interesting. And there are some of these roles which have been traditionally relegated to think tanks and research organizations around, let's say, tokenomics, mechanism design, some of the social engineering aspects, and so on, that are now becoming table stakes for building a kind of meaningful community. How do you get a community to really sort of come together around shared value system, the flow of value from one member to another? How do you incentivize or disincentivize that interaction? Those kinds of things are really coming up to the front now. Katya, what do you think?
Yes, I think I'd also say that currently the reason why it's quite difficult for a lot of people to come on board with the blockchain is that the technology is still, it's pretty specialized and maybe a little bit difficult for people to understand and, to know how to start. So in the future, the way that hopefully these type of layer one blockchains would operate would be the same way as HTTP at the beginning of our, over the line. So I would say that it seems that technologically we're really moving forward in a very fast way, and certainly machine learning has been revolutionary as of late, and the blockchain technology itself is revolutionary, and in my opinion is here to stay. The things that we do on it will evolve and perhaps change, but this idea of being able to keep these ledgers in a way that we cannot alter and that we can actually have them imprinted with the time is what's important, I think. Just to learn about now, we have such great resources nowadays. We can go online and learn, and of course we also offer a lot of resources on our website. So I will make a few posts in the YouTube chat now, because we had some questions about how can we practice smart contracts, etc. So I'll make a few posts. But I would say just keep learning about these technologies and don't be shy to learn new things, because things evolve fast and they're very interesting. So yeah, that's what I would say.
Amazing, Katya. Thanks for that. And Sherif, thanks for your views there as well. Always hard to be cornered into predictions. We've got several minutes left, so we'll let you, of course, wrap up, Sherif. But the last question for me, really, just to inspire toward, why would we be doing this, or is, could you talk about a user case that is live now that you're excited about, and then perhaps, let the imagination go out wide to where a user case could come from this new technology?
I can tell you from my perspective that the most interesting use cases as an educator are around equitable education. So it's a bit kind of silly to consider, but like, how many amazing teachers have you had in your life, Lloyd? You might be able to name them on one hand. Teachers that have really had an impact on you, right? Where are those teachers now? How many times do you think about them? And how many times have you taken a lesson from one of those teachers and thought, God, I wish I could just go say thanks, But what if you could somehow actually give them ongoing credit for, the influence they've had on your life? We can flip that and ask a teacher, how many amazing students have you had? And there will also be just a handful they can count on one hand. Katya, also a teacher, is nodding, right? So the reality is education today is sort of this moment where people come together to exchange whatever ideas, thoughts, and maybe homework, and then they disappear. But if a teacher could somehow give credit to a fourth grader who asks a provocative question that changes the way he or she teaches that lesson for the next year or two, what if that fourth grader could get a partial scholarship by the time they get into college because of the kind of gratitude that the teacher expressed in the moment and the value the sort of resonant value of that question? Again, it's a bit fanciful, but as an educator, I'm excited to see things like that. There are some experiments happening. We're funding some of those kinds of experiments with equitable education and kind of community development, incentivizing people to review each other's code and so on. You'll find that on your university, but it's still so early, as if it's 1995 and I'm talking about how excited I am to see JavaScript applications on the client side. Maybe another 5-10 years before some of these things really materialize, but that's something I'm really excited about.
Yes, there's. I was talking to Oleg, who's the founder and CEO of Sweatcoin, recently, and of course, this phenomenal pickup and traction for what feels like such a relatively simple concept, and it is you're getting paid to move in essence, and Oleg just looked at it from an incentive perspective, much like with the educational application that you were just talking about, and said, well, look, it's a problem. There's a lot of people who want to be in great shape, but have we got the incentive wrong? What if we were just to give some type of nominal token for, doing a good job on that? And then actually, what are the implications of how that affects people's wellness, the implications of how it improves their health, and then ultimately, actually, potentially the whole economy's wealth off the back of it. It's such a good example.
It really is remarkable. I mean, it's mind-blowing when you look at applications like Sweatcoin, and there are a couple of others in that same vein, but we're really just beginning to see the first hints of where this might go. I mean, direct incentivization of human behavior is certainly a clear application when money, identity, and time are native, right? But where will this go? It's hard to tell. What do you think, Katya? Where is this going?
We shall see. It's hard to predict. Like a lot of people say that we just haven't even seen, probably 90% of, what can be done on the blockchain. So it is difficult to predict. The same way, if you'd asked me in 2010, will neural networks be revolutionary? I think people just write a lot of stuff off, and then we revisit and go back to it. And then all of a sudden, with just a bit more computational power, make absolute breakthroughs. So yes, it's hard to predict, but the future will show us.
There's a comment: where does the money from Sweatcoin come from? We'll post a link after the show, and also there's a podcast I host which is called Searching for Mana, which is interviewing a lot of people like Oleg, and I'll post a link to that as well, and he'll explain it in a really interesting way.
So not specific to Sweatcoin, but maybe it's worth kind of touching on the idea that a lot of these incentive programs are, at least the sort of the first chapter of them, you can almost think of them like marketing dollars that are not sprayed out into the market in hopes of capturing attention, but directed to the early adopters. That's a really simple strategy that everybody's been following. We're not going to go out and market everywhere. We're just going to tell a few people about it, sort of a few thought leaders, few influencers, that we have this mechanism to engage our audience with direct rewards in the network and the sort of the life of this project. So that's a big sort of shift, because it's a massive spend that we're making on marketing in general, in the hopes of attracting attention.
I saw an infographic which laid out the difference between Web 2 and Web 3 creator economies, and the difference of the amount of people who would be on something like Facebook and proportionally how much they earn from producing content to in Web 3. And I mean, it is literally X100. So it's a good opportunity to lean into some of these initiatives right now. And that's where you can see, people having several different careers in the future, just by engaging into these communities for their behavior. My background, passion, and obviously what we're looking at is the future of work. If you just think and consider of something like LinkedIn, and as you were saying, Sherif, at the moment, how qualitative it is to prove your career and where you worked. And, if you're in the banking industry, then having to go and get referencing to then be able to start that job. Just imagine how, with that one simple concept in Web3, we could completely flip that for people's career. Okay, so
exciting times for sure.
Very exciting times. Yeah. We are going to have to wrap up because we're coming to 6. Thank you so much for your valuable time, guys. Anything you wanted to wrap up on, or?
Thank you for attending. Keep learning and visit all the latest layer ones, including Near.
Fantastic. Thank you so much, guys. And thank you very much, everybody in the audience.